senior academician, a very senior academician, presently or from past many years, he has been serving uh, as a distinguished teacher and professor at uh, Vishweshwaraya National Institute of Technology, Nagpur, in Department of Mechanical Engineering. Professor Kuthe has completed his postgraduate degree in mechanical engineering from Indian Institute of Technology, Roorkee, and subsequently he acquired his doctorate degree in 2001 from Nagpur University. He completed his BE from Government College of Engineering, Amravati in 1986. And may I mention that Professor Kuthe and myself share the same alma mater, that is Government Engineering, Amravati. Professor Kuthe has served prior to joining VNIT Nagpur. He was engineer. He worked as an engineer in Hindustan Aeronautics Limited, Nashik also. He has uh, supervised 10 PhD students successfully. So many national and international journals. He has contributed his papers in international and national journals. Patents filed by him, 11 patents have been filed, and he was uh, head of Department of Mechanical Engineering at VNIT, and presently he is heading the CAD/CAM Center at VNIT from more than say 5 to 7 years. So once again, I welcome Honorable uh, Dr. Abhay Kumar Kuthe sir, uh, and I hand over this session to Honorable Dr. Kuthe. Welcome, sir. Please continue. Thank you. Thank
Yes,
you so much.
thank you. Thank you, Raju, for a nice introduction. And I'm really impressed when you say that both of us are share the same alma mater. You know, about the Raju with whom I'm closely associated for the last so many years, even after the graduation. The only difference what I see after looking at him and then looking at my photos simultaneously on the same screen is that it seems that many of the times I feel that I'm already retired and he is the person who is just joined the institute. So thanks for a very nice young look, Raju. And I'm thankful to you for inviting me for this particular uh, FDP on the Industry 4.0. I'm really impressed because I have seen Nanded College, Polytechnic College, very active in organizing this FDP on Industry 4.0 because last time also I had delivered a talk. That time I had delivered a talk on the Industry 4.0. Now I'm
Yes, sir.
delivering a lecture only on one component of Industry 4.0, that is 3D printing.
Yeah.
So nice to meet Raju and all the management of the uh, Nanded College, and thanks for inviting me. So, without wasting more time, I think about the whatever the introduction Raju has said, I always used to say my students also that I like the advertisement of that ghadi detergent tikia. So पहले इस्तेमाल करो फिर विश्वास करो. I think the everyone should believe me once I deliver my talk, like whether I'm really worth for whatever he has already informed about me. And it will be quite interesting for all the participants if they can visit our campus at VNIT. And the CAD/CAM center, which I am now presently heading, you can see in the background the CAD/CAM center, which we have now remodified with one more floor. And I wish to rather inform you also about what exactly we are doing there and how it is related to the theme of this particular FTP. So let me share the screen so that I can then show you the Uh, yeah. Can you see my first slide in maybe in presentation mode? I will just put it there in the presentation mode. Yeah. Can you see my slide now in presentation mode?
Yes, sir. Yes, yes. Very
Yeah,
much
yeah, yeah,
clear.
yeah. Sure, sure. Now, the title of the lecture is quite catchy because of that Atmanirbhar particular word. And this is the buzzword nowadays. Everyone talks about Atmanirbhar Bharat. So, how it has rather related with the Industry 4.0 and more specifically, that how it is related to the 3D printing, which is again a buzzword in mechanical engineering or in generally engineering institutes or engineering field. So I will be focusing more on that how the 3D printing research is to be executed or is to be carried out. And not only that, but then what we have done and how it is related to the Atmanirbhar Bharat. So the picture which I'm just showing you on my slide is the VNIT at night. It will be quite interesting for you to visit our campus, 300 acres with a lot of greenery. And uh, it's not only about the academics, but we do have good number of bird watchers visiting early morning. A lot of birds are there. So please do come and enjoy the nature by visiting our institute, and I will be really happy to rather entertain you as a guest in our VNIT. So please do come. I'm also serving as an adjunct faculty of research for research at the TM Institute of Medical Sciences, Varda. So that's also an additional portfolio which I'm bearing, and I'm quite happy with that because I'm closely associated with Medical Institute also, and how exactly it is related with whatever I'm doing. It will be quite interesting for me to discuss with you. So the agenda for today's talk is before that, let me show you that this is a CAD CAM center, and these are the quickly some of the state of the art machineries like 3D bioplotter and all that, which is very important from the point of view of amalgamation of engineering and medical sciences. And 3D printing, the FDP machine, FDM machine that we do have, which is also called by the name FFF also. So let me discuss with you the outline of my lecture, the introduction, Smart Foundry at VNIT, then Betic at VNIT. This is about what exactly we are doing at VNIT. Fourth one is about the startup success stories, and finally the conclusion. Nowadays, the because of the lot of information which is available on the net or everywhere, the thing is changing very fast. Whenever anything is to be learned, hardly you need tutor. Just click it on the Google, and hopefully you will get a lot of information, and you will also learn more about that concept. So then I always start thinking like, what exactly I'm going to discuss with the audience when I'm delivering a lecture. And that's why, I wish to tell you what exactly we are doing in our institute and how it is related to the theme, recent theme or the theme of the FDP and all that. And that will rather instigate all of you to do some more and more work in that particular domain. Otherwise, what happens, when we actually click on the, or when we surf the net and when we click at a particular so-called topic of the interest, so much of information, and that's why the word information explosion is the right word. It's like an explosion of an atom bomb. So much of information, and we get tired after looking for that particular so-called mm, uh, topic of interest, and we feel that okay, enough of that. It's like getting more and more information, but that hardly leads to any knowledge. So getting the information which will actually create a knowledge, and that knowledge which is deployable, I think that is what is the need of an hour. And for that purpose, I generally set the outline of my lecture, focusing more on what we have done. And I'm also interested in the last one, that is a conclusion. So, conclusion, sometimes we feel that, okay, once I start showing the slide of conclusion, everybody will say, okay, fine, that's the end of the lecture now, say bye bye to everybody and all that. I think no, that is important. There has to be some takeaway message. And that takeaway message is important. And after the our discussion, after my lecture, after our discussion and all that, say if you recall that takeaway message again and again, I think we are successful. So that's why I give more importance even to the conclusion also. And uh, but to see that everything is very easy for everybody to just take a message from the discussion. And that's why I put more and more focus on the conclusion also. So let us start with the first introduction. Now, this is what all of us are aware of in 1991. It's an impact of globalization. We talked a lot about globalization opening our market to the all industries from the advanced countries. That's what we call as the world leaders, and we have opened up our market to them. And a lot of companies, they have started selling their product also in India. And then all of a sudden, we start talking in say 2018, 1920 about the concept called Make in India. Now, this is somewhat very confusing to most of the people. And what the people feel that, oh, you say that in 1991 everything is open for the world, so the companies can come from the advanced country to our market, sell their product and all that. And then now you said about the Make in India. So this is somewhat confusing to most of the people. I think we need to rather first look at this Make in India, or that made word is particular make in India. If you go through the Google and just look at the this made in label, which is very catchy. And right from our childhood, we are always used to say, "Oh, made in Japan." That means it's the best product. So the wristwatches used to come from the Japan. So you say, "Oh, made in Japan. This is a watch from the made in Japan. This is a watch from the Switzerland and all that." So this made in label, if you look at, then the very nice study has been executed, and this is presented in the form of a data. So you can see that the what are how this made in labels is respected in the world, and from the so-called consumer perception point of view. So very nicely it is indicated when they say that Germany vehicle 100% perception. That means all consumers are satisfied if the vehicle is from Germany. And this is how they have actually shown. I'm surprised to see the India is ranked for the refined oil. So I don't know how far this is been taken care from the numeric and the data that they must have been already gathered. But this is wonderful, and you can see that generally in case of a vehicle, in case of the say iron ore and all that, so European countries are very much popular and all that. So this made in label, when it is so popular with the advanced country, and that is what you will see always in this list, the most of the time the advanced country. So now what, how comes that this make in India is will, or rather will make an impact? So for that, let me show you an interesting picture here, that this Atmanirbhar Bharat and Make in India is almost complementing to each other. Or rather, I should say that Atmanirbhar Bharat is an advanced version of the Make in India initiative. So it is very much related to the Make in India. Let us look at it again from considering the 1991. That is the area time when the globalization that was open to us. So I think this picture clears everything. You know, I'm just showing an Indian, and he is balancing two things. One is the premium quality product, and other one is Make in India. See, as soon as it is open, the market is open for the advanced country. That means our market is open for advanced country. The premium and quality product from the advanced country has actually entered in the market. And now we are talking about Make in India. That means the product is to be manufactured in India At the same time, the quality product, what we generally believe that it always comes from our advanced country, is also in the market. So naturally, you will have to always balance that the product that is made in India, that the product which we call it as a make in India, should have the same quality as that of the quality of the product that we get it from advanced country. And that's why that particular Indian, I'm just showing balancing these two things, like the premium quality product and make in India. And that's how exactly the impact of globalization plus make in India. And therefore, the Atmanirbhar Bharat focuses on this particular issue. So there is a tremendous, rather responsibility on India or on India on the Indians, especially in manufacturing sector. And then there are a lot of chaos if you just look at this particular picture. What is a premium quality product and all that? So, for example, when we say that a product is from China, how do you look at it as a premium quality product? I don't know. But you will definitely say that, oh, it is the cheapest one. And everybody would like to buy it. And it has the market. And there is another one called the vehicles that are actually imported or which are manufactured in the country like Germany, about which I have already shown you that. And they are very costly. So cost is not an issue here. And quality is also very important issue. So how do you balance that? And there will be a lot of chaos and a lot of discussion going on. So ultimately, what exactly it leads to? It leads to more and more confusion. So when it leads to more and more confusion, what we should do? So that's what exactly I'm just showing a smiley. The person is getting confused. So let me recite here the Sanskrit shloka, which I think most of you are knowing. Where at the end they say that Mahajano Yana Gata Sapanta. So what we need to follow, the eminent personalities or eminent path, where you will find that whatever the path the eminent personality follows, that's the best one. And that is what we all know. Our past president, Honorable President Abdul Kalam Sahab, they say that we need to rather change our status from developing countries to the developed countries. That means we should follow what the developed countries are actually doing at this particular moment. So, when you look at it, I think the Industry 4.0 is the uh, area where they are all focusing. It is all started from Germany. I think many of the speaker must have already discussed about this, and you must have also gone through the net and must have seen about that, about which everything is been indicated. I'm just showing you one uh, picture out of that, which just explain about how it has started first to second, second to third and fourth. So no need to discuss about it in detail. Most of you people are aware of that. But then I am more interested in what is called as this degree of complexity. If you look at that particular slide, the degree of complexity is interesting. What actually it indicates that when you move from first revolution to the second, from second to third, and from third to fourth, the degree of complexity is increasing. And in the fourth industrial revolution, the degree of complexity is maximum. Now, there, I think most of us are not focusing our attention. Though we talk a lot about the industrial revolution, one, two, three, four, but about the degree of complexity, we don't talk more. And what is interesting here, if I wish to just show you the nice picture, that the engineering colleges, academic institute, those who are offering the engineering education. Now, I'm just correlating that with the first industrial revolution and the academic colleges. Now, that time, I'm just showing you that how the academic institutes and engineering colleges, they were all related. But when the degree of complexity is less, that time the how far the academic knowledge we should rather impart to the student, that is always taken with a pinch of salt. And and hence that time you'll find that even the IT institutes used to flourish like anything. And most of the people used to go to the ITIA, and even if the 8th standard pass student candidate used to go to ITIA and used to get some experience in a particular trade, and used to work in the industry. It is because the complexity was the lowest. Now, when you go to the next, then you know the these you have the college of that means the academic institute and the industries. They need to come together. That, but still, the complexity is not much. What I would like to tell you here is that as the complexity is increasing, naturally the academic institute has to come in close contact with the industry. Otherwise, who else is going to rather help industry in overcoming the complexity in an industry? So here in the second revolution, hopefully we were always talking about, oh, academic institute interaction has to be there and all that. But ultimately, that was again taken with a pinch of salt and question mark, how far the academics and institutes are coupled. But then again, when you look at the third revolution, as soon as this IT, electronic components and everything has started, the College of Engineering, that means academic institutes, are now coming close to the industries. And now, when you talk about the fourth industrial revolution, the academics has to come very close to the industry, and industry also needs to come very close to the academic institute. I think that is what you need to look at. Industry 4.0, when we say that, that means the academic and industry needs to work together. Now, no other way out. No industry can say that, oh, I don't need any academic people from the academics or anything from the, or academics people, they don't look at the industry as if they don't practice whatever we tell them. So ultimately, what exactly it means when I'm just showing you here the how the academics institute is closely approaching to the industry. In academics or in higher education institutes, we don't, rather, we not only focus on a particular concept of engineering, but we also research on that topic. Say, for example, in case of a casting, most of you people are aware, like there is a concept called riser, or we call it as a feeder. When I visited many foundries, I found that they don't look at that concept as very important. They say that, sir, because of that, there is a problem with the yield. And they say that pouring basin itself is their rise. Then I realized that they are not aware that the riser or that feeder is required to overcome the shrinkage cavity. And then when we teach them, I think that is what exactly is the need. So then why do you teach them? Why there is a need of teaching them? It is because in Industry Revolution 4.0, the ultimate aim is to get the defect-free product. Remember, this is very important, and all of us should understand this very carefully. Defect-free product in one go, first go. And interestingly, this is required because the resources are to be used optimally. Earlier, in all the industries, hardly any focus was there on the resources utilization. But now in Industry 4.0, there is a tremendous focus on industry revolution in the resources utilization. And therefore, when you actually go through the so-called various areas where more and more focus has to be there in Industry 4.0, you'll see that there is a simulation and the big data analytics. I'd like to just give you quickly over the all this area. The simulation talks about the simulation softwares for the processes which will actually inform the people that what type of the parameters they should set on the shop floor. And big data analytics is actually the analysis of the data that gets generated because of the practice on the shop floor. And then ultimately overcoming any problem in the process so that the product will be defect-free in first go. So all these things, whatever we are now showing here in Industry 4.0, they're all important from the utilization of the resources. Out of this so many field which I am just showing it of the Industry 4.0, my focus is on additive manufacturing. That is on the 3D printer. And it will be quite interesting for me to just tell you how exactly this additive manufacturing is important from the Industry 4.0 perspective. And not only for that, but even in general, how it helps.
getting the research deployed, because the research is done in the academic institute, and how it gets deployed for the benefit of people. Okay. So, when we talk about the industry 4.0, it indicates there is a need of innovating design, and how that innovative design is possible to manufacture. And that's why I mentioned in a very simple text sentence, there is a need of innovative design and checking the feasibility of the manufacturing of that innovative product. So ultimately, there are two interesting issues. One, when you talk about the product, you should see that it should have value. And when you talk about the data, then it is to be linked with the analytics, because ultimately more and more data generated should help us in developing what is called as the decision support system, or we may call it as a decision making system also, which is quite complex, but still you can definitely think about the analyzing the data to see that your decision making system is ready, and that will again help in getting the resources optimally used. Now, another interesting point about this 3D printing, about which I'm going to discuss, is that we should always talk in terms of the three R's. What are these three R's? It's not only related to the application of 3D printing, but application of any new concept in engineering. It should always go with the three R's. What is the first one? The first one is relevance. That means why this is required. Why is it required to go for such new concepts like, let's say, 3D printing, if at all we say? Is it really required? That is what is the first R we should first look at. Secondly, the resilience. When you talk about the resilience, it is indicated, that's what I mentioned in the bracket. If you feel that it is required, then once you implement it, it should not fail under any condition. So remember here, relevance and resilience both are important. And the third one is top of all, where we talk about the responsibility. And when you talk about the responsibility, remember, it is indicated that the organization is committed towards the ethical and responsible new concept, which is, say, for example, 3D printing. So just to give you the glimpse of this 3R, suppose I enter in any industry and I've said that, oh, 3D printing is very important, you must use it. Then first I should be in a position to explain to the decision makers that why it is required. And I should also inform them that once we implement it, it is my duty to see that it will not fail in any condition. And if you can handle this first two R, I think the third R is to be handled by the industry, by the organization. That means it is the whole organization is committed to see that that particular concept is now through. So from these three R's, we'll have to always look at any new concept. And I'm going to discuss about whatever we have done from these these three R's, and how it is important in general for any industry. About the Atmanirbhar Bharat, I wish to just tell you quickly in introduction itself. Now, now the manufacturing industry is a customer centric, because now the innovation and comfort plays the dominant role. There is more focus on research innovation, customer. And that's how I told you. Like when engineering institutes are required to come close together to the industry now, so naturally the research that is carried out in an engineering institute is now getting a chance to get deployed in the industry, and through that to the customer. So this consumer centric manufacturing industry is very important. And that is what is the need of an hour. That is where exactly we need to focus. And that's why I mentioned there is a need to focus on high end knowledge and research. It's not that only, I should not say low end knowledge means like getting some knowledge in the graduation or at the our course curriculum, which we generally talk it as a low end knowledge, is not to be looked as an important one. But everyone has to look at high end knowledge, to which we call it as a research, where we always say that innovative and tailor made product is the need of an hour. Now, here, look at it from the our traditional industries. When you look at the traditional industries, big industries which are operating like L&Ts, Tatas, and all that. So, these industries is not in a position to rather make the product which is innovative. So, big no for they are actually set up with the mass manufacturing, where the product gets manufactured in masses, and ultimately it is difficult for these industries to enter into the domain of innovative tailor-made product, and that too changing as per the customer demand. So what is the solution then? If they are not in a position to get it done, who else is going to do that? For that, the startup is the only solution. Remember here, the through this startup, all this thing is achieved. And I'm going to rather link all these things with our title of the topic, Atmanirbhar. About this startup, I'm really very happy to tell you one of the very nice interview which I have read it in Economic Times in August 20. Nandan Nilekani, he has been asked a question about the future of an India. So a simple question and a very nice answer which he has given. He has been just asked the question, and that's what I'm just putting it for you. Very easy to read. And he has been asked the question: you think the future for India will be where more small players also compete? He has answered it very wonderfully. He said, "I'm of the firm belief that it is not about few companies creating millions of jobs, but millions of companies creating a few jobs each. That is what I see as the future." Now, when you look at this particular statement, I think now you will definitely look at my slide where I have shown the big no for the traditional industries or the big industries, mass manufacturing industries. You can't expect the big industries or the large industries creating millions of jobs. Can't expect that the Tatas will come out with more and more jobs. L&T will come out with more and more jobs, and all the millions of jobs is required. So they can't do that. They may face the problem even to sustain the jobs, whatever they do have. But now, millions of companies creating the jobs each, that's what exactly we have said from the startup. So, if we have the millions of startups and all the startups are creating few jobs, I think the problem of the job seeker is solved. We should not say that the we should this is a very wrong statement when the people say that be the job creator and not the job seeker. No, that's a wrong statement. Job seekers will be always there. You should say that be the job creator and see that the problem of job seeker is eased out. So all the job seeker has to get employed, and for that you need more and more job creator. That's a wonderful statistics which has been shown by the economic survey on the startup, and that's a wonderful report of ET. I'm just marking there with the right mark. 4,70,000 jobs created by more than 39,000 startups. Just imagine, can this much of jobs gets created by the traditional industries who are actually focusing on the mass manufacturing? Big no for that. And that is how I think in the whole introduction, what exactly I wish to tell you, there is a need of the customer centric approach. What exactly the industry 4.0 we should look at. And finally, startup is the only solution everywhere when we talk about the word innovation. Okay, let me go to the next very interesting point here. That a concept, the project that we are now executing at VNIT, Smart Foundry. Okay, I'm happy to show you this particular picture. It's a multi-institutional, multidisciplinary project, and we all of us are working. Like I had just shown you the logos of the institute which are closely involved, like CSR NEAST, IIT Bombay, then the College of Engineering Pune, VNIT, Jadavpur University, CMTI. These are the major so-called the stakeholder in this particular project of Smart Foundry. Even as I already mentioned to you, like in the background you can see our Caricam Center and Smart Foundry board. Now, this SMART talks about the sustainable metal casting by advanced research and technology. I'm very happy to tell you that Professor B. Ravi of IIT Bombay, he is our mentor, And he has guided us very nicely in this particular project, which is having the total financial outlays of around 9.60 crores. So here, what is interesting for me to tell you that this particular smart foundry project, how it is related to the concept of the industry 4.0 that we are more interested in looking at. Now here, I'm just showing you in a um, uh, simple schematic, like how exactly the whole smart foundry is operating. But it will be quite interesting for me to just show you an interesting thing here. I will just try to use pointer if possible. Yeah, it's possible. So now here you can see the part CAD. That means the you have the file in CAD mm, uh, format, and which were the computer design, and then you use it for 3D pattern printer. So 3D printer plays an important role in the whole system. And secondly, what is interesting here, if you look at the sensors and all that, it is the data that gets generated, and we are now actually executing the analytics of that data. So, in one word, if you look at the last line, adding intelligence to manufacturing using cloud, big data, and analytics. Remember, here it is very interesting. And I have just indicated that related to the manufacturing. So it's about anything that you can then relate it. And just we are focused on the foundry, but you can relate it to any manufacturing. Now, when you actually enter into this domain of embedded, let me show you the version one, which we will be now installing very soon in VNIT. A very simple sketch where you can see the design and process simulation of the whole process is being executed on the computer. That means whatever you do on the shop floor, it is possible for you to first get it done on the computer, a complete simulation. Even whatever the part you will be manufacturing or which you will be casting, you can see that on the first computer. So, and even what will be the cost of that, even that also you can decide with the simulation software, and we are using the AutoCAD software. Then that is used to get the 3D printing of the pattern. Then this will actually get connected to the mold process, automatic molding. Then we do have the gravity casting, and then fettling and finishing. That is what ultimately the last part with the finishing here. Now, all this thing is quite interesting because everything is possible to see on a process display. And the owner of the foundry, he can always see on his mobile what is actually happening on in his foundry, where the part is going, whether the part is in the melting pouring unit, whether it is on the molding unit, or whether it is getting printed in the 3D printer for the pattern. So this display is very important. And let me show you an interesting thing about the smart foundry unit, which we have already developed and which is now presently installed in CMTI. I think this is quite interesting, this one. You can see on a dashboard, this is what we call as the dashboard, that how the part is getting simulated. This is a complete simulation of the part. Then how exactly the part is getting ultimately the executed in the melting pouring, and ultimately how it is actually getting executed in the other processes. All these things are very nicely explained on the dashboard. So this is what the unit is. Here you can see the 3D printer. Here you can see the mold making machine. Here you can see the melting and pouring. This is for the fettling and this is the dashboard which I just showed you here. Now, this is very interesting. Now, let me show you that what exactly we have achieved when we look it from the 3R point of view. So, when you look at the 3R point of view of the smart foundry, then I wish to just tell you that we have defined what is called as 25 by 25 by 25, 25 cube. What is this 25 cube? 25 years of an engineer having a 25 lakhs as the financial resources and 25 square meter the land, he should be in a position to set up his foundry. Why the foundry to be set up? It is because he has developed some innovative product and he wants to show the feasibility of that innovative part using in his smart foundry which he can develop. Remember here, it is very interesting for me to tell you that when I say that it is the feasibility of manufacturing, that means the innovative part, if at all it is having the more and more complicated feature, which is rather required, about which I'm going to tell you rather. So here, more and more feature in the part, more and more non-linear feature in the part, which is always taken with a pinch of salt by the traditional industries. So here, if you can involve that to give the comfort to the customer, then that engineer should show, or he should show the feasibility of manufacturing through the smart foundry. How the three R's are achieved? The first, relevance. Why is it required? That's what I told you. Innovative product, need of the hour, which is having more and more complex feature. And solution to the underemployment. Yes, we have seen that many people, they do have very good rather the education, maybe MTech and PhDs and all that, but later on lands in a job which is not befitting their state. So this is a wonderful solution. And another interesting point, which is the uh, core of our discussion, is this startup ecosystem. It creates an ecosystem for the startup. So this is what exactly the relevance. Yes, it is required. Then resilience. Once implemented, should not fail under any condition. Now, how I'm going to look at it? The design conceptualization. That means the product that you are designing, which you call it as an innovative product, needs to be conceptualized, needs to be the concept of that product needs to be designed using the well-tested so-called the techniques called trees or the biotics. This is interesting. This is important. If you do that, it will never fail. Your design will never go out of the fashion once you implement the bionics. Okay. Then focus on TRL 5 to TRL 9. We generally, I think most of you people must be aware of the technology readiness level. We only talk from 1 to 9, and then we focus only on 1 to 5, where exactly we are quite smart, we are quite comfortable, because we need to only talk about the pen and paper or something on the computer, and we say that, okay, my design is ready, my design is safe. But you know, your design is safe. But whether that design is accepted by the customer or in the market or by the entrepreneur to see that it manufactured in more number, that is decided by TRL 5 to TRL 9. So focus on that. If you focus on that, your product will not fail in any case. And another interesting point, data driven decision making, about which I already told you. Like the data that you generate, maybe that is in the smart foundry. So that should help in developing a model, which will always helps in taking the decision. So resilience. And third one is responsibility. Organization is committed towards that, and that is what I mean. Strong linkage of industry and academics. It is must. So when you talk about the 3D printing, and if there is a strong linkage of industry and academics, then naturally it is definitely going to fulfill our third R, that is responsibility. And the organization will be always committed towards that, because whenever they face any problem, they can anytime approach the academics, and academics also can interact with the industry and see that the whole thing gets developed in a robust form. Let me tell you here, very interesting point, that in most of the advanced countries, you will find that the industries, they are having a close connection with the research institutes or the academic institutes. It is because they need to always think about the newer and newer innovative products as they enter into the world market. Okay. So this is one of the nice thing which I would like to just tell you. And we are now in a process of developing the version 2, where you can see that it is developed in by say casting design somewhere in Trivandrum, process data analytics somewhere in Gujarat, 3D printing in Pune, mold making somewhere in Nagpur, melting pouring in Nagpur, and then sand reclaimer is somewhere in Kolhapur, regulatories are Delhi, board, and all of them are connected with the cloud. So this cloud technology, we wish to use it in this smart foundry operation V2, which is rather getting developed in Bangalore. So once it gets developed, it will be quite interesting for me to share with you about this particular nice project. And this project, which we always call it as a smart foundry project, is now popular everywhere. And it actually shows a glimpse of Industry 4.0. Remember here, Why do you want to go for all these things? Because the product should have the zero defect, and it is using 3D printing, it is using the simulation software, it is using the data analytics, and all the aspects which are generally the core of an industry 4.0. Now, let me take you to the another interesting point is about the basic VNIT. Now, what exactly at this particular project, Basic VNIT, we are doing? It will be quite interesting for me to tell you because I'm closely mentored in this particular project by Professor B. Ravi. He's the PI of this project and the PI at VNIT. He's PI of overall multi-institutional Basic VNIT. So let me first tell you something related to the medical devices in India. And that's what I mentioned. Let data speaks about it. What the data is indicating that the medical devices imports in last 5 years, very disturbing figure, that the 23,000 crores to now almost 38,000 crores and still increasing. Now, about this, if you look at the medical devices breakup, you'll find that the electronics, consumable, and all that, the percentage, electronics and equipment, no doubt it is having a more percentage of import. But what is interesting here for me to tell you about the implants. Now, why I'm talking about the implants, it is because implants needs the mechanical engineering assistance. And therefore, my focus is on the implant, and that's where exactly we have actually carried out our work. Now, when I interested in informing you about the implant, let me also tell you that the there is a need of research to be carried out in implants. The implants which are fitted into the patient body, especially the orthopedic implant, to which we call as a load-bearing implant. That means the implant which is fitted for the substitution of the bone. Okay. Now here, the another interesting point, which again disturbs us a lot, when you look at the patent filing trends in medical devices, then it is very disturbing because here you can see the pie chart and the last sentence is very problematic for us to read. What it indicates, the figure depicts the dominant of IP fillings of about 80% of the total by the foreign applicant. That means the foreign applicant, they file the patent in India and ultimately capture our market. And it becomes difficult for us to enter in that particular devices because the patent is already filed by the foreign applicant in that particular domain. And why they should not do it? Because they have already developed the innovative product. They want it to market all over the world. And that's what exactly the case. And 80% total by the foreign applicants. Rest are all Indian applicants. That means the Indian applicants patent filing trend is very, very poor. It means that the research is not being executed. Patent means nothing but research. So we are not actually doing any research in the plan. That's what about the in medical devices I'm just talking about. And ultimately, what you'll find that we are lagging or we are lacking the so-called motive for the research, and that is to be looked at. So let me tell you about the position in case of a metallic implant standard. And metallic implant, these are only very cold to us. Now, when you look at the metallic standard implant, there is a stiff competition with the manufacturer from developed country. Yes, that is true. And I'm just showing you in the picture the various implants which are fitted into the patient body. What we have done, when we actually interacted, or rather when we actually get involved in the research in the implant, then we thought that if at all we start thinking about the import substitution of the standard implant, hopefully we may not achieve anything because the implants are already in the market, standard implants are already in the market, and top of it, the medical fraternity has developed a very close, or rather they have developed a very nice confidence about that particular implant. So, a very simple, rather the thing I would like to just discuss with you. If you ask the patient that which type of the implant is to be fitted in his body or her body, whether the Indian implant or the, say, foreign implant or the imported implant, what answer the patient will give? Patient will say, oh, doctor sahab batao kya karna, what I should do. Because ultimately he will again look at the doctor. It is the doctor who has to actually treat him and see that. So doctor will say, okay, I feel the Indian, but they are imported. They know that is always better. So it is because he has already developed the confidence in the imported implant, which is easily available, and he has already done lot of cases where he has fitted the implant made in advanced country. So that's very tough, very difficult for anyone to enter into such domain where the standard implant has already established their credentials. What is interesting for us to look at, that is where we have rather started working on, is on the customization. That means whether it is possible to customize the implant, that means the implant suiting to the patient's anatomy, whether we can do it. And that is how we have started. So let me tell you about this is wonderful implant like hip implant, because that's the major implant which is always fitted into the patient body. We have actually considered the various parameters which are very well documented in the medical literature. And we have seen that the parameters like vertical offset, horizontal offset, anterior offset, neck shaft angle, they are the parameters which are always considered. And then out of that, though we have taken the case data for all these parameters, I'm really impressed when I have seen the variation of the neck shaft angle with the number of patients. Now, this is a very wonderful data. This is what we have collected about 222 patients. And these are the patients from central India in and around Nagpur. What you can see here, the data, it is very scattered. That means the maximum is 140-degree angle, and another the lowest is 124-degree angle. And you can't draw a median line in between saying that, okay, 132 is the right figure and just get the implant manufactured of 132. No, it's not like that. So here we have seen that there is a tremendous variation of the neck shaft angle. So ultimately, what is required to be done when you talk about the customization, that means suiting to the patient's body. I think we are all engineers. If I, we will not talk only about the 126-degree. We may say that 126.44 degree of that, the neck shaft angle of that particular patient is 126.44. So just fit it that, because we are so close to accuracy. So ultimately, that when we talk about the customization, naturally we'll have to be very systematic in the sense that what next shaft angle we need of that implant. And when you say that, when you ask the doctor that this such implant is to be fitted, then doctor will look at you. They'll say, "Oh, you are an engineer. Give me that give me that type of an implant." And this is only possible when you enter into the 3D printing. Remember here, 3D printing is the technology which has actually revolutionized the whole biomedical engineering. And this is a very simple thing, a self-explanatory figure. All of you are aware of that. You can Google it and get more and more information about it. Like converting the CAD model, that means the model which is available on the computer, to physical model. A simple steps which I have just shown you, how the CAD file is converted into a slice file and all that. And we have seen an wonderful, or rather interesting issue about the 3D printing, is that the 3D printing data can be, you can exchange the data from CT scan. That means you can export the data of the CT scan and import it to the 3D printing, and it is possible for you to get the model or the physical model of the medical organ. So it's a computer tomography and 3D printing. It is not about the computer tomography. Even the MRI is possible. Nowadays, even they talk about a sonography, whether it is possible to get that particular in a 3D printing and all that. So we have actually seen this use, and then finally enter into this particular domain of implant manufacturing using RP. This is interesting. So you can see that the data is exchanged, and then this data, it will be now giving us the medical physical model of a medical organ. You can see the complexity in the medical organ. See the non-linearity in that. No one can manufacture it. No traditional manufacturer using the lathe or other machines, they can manufacture such things. But 3D printer can give you, and then you can use it. Maybe any manufacturing route. We have done it with the casting, and this is the first implant. This is the first metallic model that we have fabricated in VNIT in 2007, and actually it helped us in getting the project on this, which is development and testing of customized joint replacement implant using layer manufacturing. Now we have actually executed, or rather we have carried out this particular project from 2009 to 2014. And here you'll see that this is, I'm just representing in the form of a cycle. We don't want this cycle to be completed because we don't want a healthy individual to meet with an accident or he should be a patient. But ultimately, the whole project shows that how the CT scan data is converted with the medical imaging into the data or the CAD data of an implant which suits to that patient, and ultimately how you use it in by using the rapid prototyping 3D printing and the casting simulation software to set up the parameters on the of the shop floor casting, and finally manufacturing the metallic implant and testing it and then fitting it into the individual to make him healthy individual again. So this is a wonderful project that we have completed. Let me show you some of the nice case studies that we have executed. This is about the metallic implant that we have fitted into the patient body under the temporomandibular joint. See, the whole thing is very, very interesting, but the details of it you can always read it in Rapid Prototyping Journal, volume 17, number 5, which we have published in 2011. Interesting part here is that the how we have rather designed the implant, and because the engineering point of view, design is important, and how we have interacted with the doctor. So I wish to just show you here an interesting point. You can see the clay model. I always used to tell it to students also, that how this clay model helped me in interacting with the doctor, because doctor is having the idea of how the implant should be. He is not aware of how much stress and everything that comes on that, but he is aware of how the form should be, because it should be possible for him to fit it into the patient body. So he was not in a position to draw a drawing on a paper, because that is what I need for the manufacturing point of view. From the design point of view, the doctor's handwriting is difficult to read, and I'm asking him to get the drawing of it, when and that too related to engineering. So it was very difficult. But when I told him to give me the clay model, then this is the first one which he has done. Then with that clay model, we have reverse engineered the data, and we got a CAD model. That CAD model we have sent it to the RP machine. RP machine has given us the model, and that we have rather with lot of iteration, we have now finally come out with this particular metallic implant. Okay, this is manufactured in Nagpur, and ultimately we are fitted into the patient body, and you can see this is what is the deliverable. The girl, she was not in a position to open her mouth for almost 6 years because she met with an accident with some trauma, and now after that she was in a position to open the mouth. And it was something very interesting. Lot of things I can discuss with you, but with short of time it will not be possible. But let me tell you one interesting thing here, that when she has taken the first bite of the samosa after 6 years, when that one was offered to her during the press conference, and the satisfaction I have seen in her eyes after eating that samosa, I think that satisfaction I had never seen in my life, when I got the PhD or when I got promotion or whatever. That actually shows that how you are serving the society. And another interesting point is that this we have fitted in 2007, though the paper is published in 2011 because of the so many revision and all that. So 2007 we have fitted, and now in 2021, recently some 2 months back, that lady, now she is not a girl, she has married now, she has one daughter also. When she has visited Nagpur, it was so exciting for all of us to see that with me and my doctor, that she is still operating very comfortably with that particular joint. She is very happy, healthy. So it shows that whatever we do for the people from the bottom of our heart, especially with such type of the 3D printing and all that, that always serves the purpose. Okay, and then we have done a lot of cases like metatarsophalangeal joint implant also, that we have developed again using the 3D printer. You can see here the 3D printer. So this we have used it to get a metallic implant. Even we have done the stress analysis of that using ANSYS, finally fitted into the patient body, and these are its reports after the 2 years. So getting a feedback after 1 year or 2 years. That also is very interesting. You can refer this journal again, 2014. There we have indicated. Another interesting thing is about the malignancy that we have noticed in case of mandible, and how we have actually helped this patient to overcome that, because we have fitted. There is a need of resecting the mandible. You can see here, this is resected, then this implant is fitted, and now the lady she was suffering from cancer here, ultimately she is fitted with the implant. So this is again available in Journal of Maxillofacial Surgery, volume 71, number 2, 2013. You can definitely go through this one whenever you have this time. But what is interesting here, the one more the stage further, I wish to write this particular word no. What no indicates? No indicates that there are so many S inside. The metallic implant which we fit into the patient body, they are always subjected to criticism. Why? Because there is a concept called stress shielding. You can see this figure very nicely, and you can see the tennis player holding the racket. So, when you take a X-ray of the bones of the hands which is holding the racket and which is not holding the racket, you can see that the bones gets developed very strongly in the arm where the racket is always held. It That is what they call as load the bone. You will find that the bone will develop. And don't load the bone, what happens? The bone resorbs. Resorption means it will slowly get slowly will not develop, and ultimately there will be a gap, and that is what they call as the stress shielding. Now, with the metallic implant, there will be always a stress shielding, and finally, what you'll find that there will be the implant loosening. So you can see this again here. If I'm just showing it, so this is loosening because of that. The whole load is getting transmitted to this metallic implant because it can sustain the. But these bones, which are just outside that, they are not subjected to the load to which they are supposed to. And finally, they resorb. And when they resorb, there will not be any bone at all. And that's how the implant loosening. So, what is the solution to that? The solution is to enter into the another domain called scaffold fabrication. And this is the extension, logical extension of the 3D printing, to which we call it the 3D bioplotter. And we are also working on this scaffold-based tissue engineering, 3D printing, which is very useful. And this is the complete cycle of bone tissue engineering, where we are making the scaffold. The scaffold is implanted into the patient rather than the metallic implant. And in the scaffold, slowly the bone tissue will grow, and the implant made of bone. So that's what we call it, the bone tissue regeneration is possible. So this is what exactly we have done. So again, let me take you back to the 3 R's. What 3 R's we have taken from the basic DNA? The first one is why it is required, relevance. Whether it is required, yes, import substitute implant. And what we have done, rather than unnecessarily spending more time on the standard implant, we have started working on the customized implant, which actually serves the. And again, the very interesting point after the customized implant, the startup ecosystem in class C and D medical devices. This is important, which in advanced countries like European countries, they call it the class 3 device. In India, we call it as a class C and class D medical devices, which are always high risk devices. That means where just like the implant is fitted into the patient body, it's a high risk device. So here what you'll find that we need to create an ecosystem, startup ecosystem, where the class A and D medical devices will be invented and manufactured. Class A and B, they are low risk devices, and there is no rather more focus to be given on that. And many people, they do it the way they create it on with their own imagination, but hardly any focus is there on the class C and D medical devices. So that's what exactly in Batik Venite we are. Resilience. So the resilience is that the Batik philosophy works with the define, develop, deliver, and deploy. That is what we follow. What do you mean by that? Define means we start with the doctor, because the doctor is the person who is the customer at the end. Though patient is the person, but through the doctor only the patient will listen. So we take the doctor into confidence right from the first stage. Develop all the 3D printing and the latest technology data analytics that we do uses to develop that. Even we use the trees and the bionics to get the design. Deliver. we convince the entrepreneurs that this is what exactly we should do, you should do, or rather the entrepreneur should do, and finally deploy. That means, as indicated in the again same thing, TRL 5 to TRL 9, there we need to focus, and that is how we do it in Basic VNIT. And top of all, as I have mentioned in the last, confidence of medical fraternity, that is only possible because our first stage defined. With the define, we take the doctors into confidence, and that doctor who helps us in design and the deployment and develop everything, he is our ambassador in the medical fraternity. Ultimately, he actually help us getting that our research deployed. And interestingly, as you know, it is a strong linkage of medical and engineering. That's why I told you my association with the Dean Institute of Medical Sciences, Varda, actually helped me in getting all this thing done. And I'm so confident about what exactly we are doing in the research in this biomedical engineering, which is related to the industry 4.0. Okay, so let me tell you an interesting thing here. The fourth one about the startup success story. What exactly we need to do as here the customized design, which is an unmet needs. So we need to focus on that. Okay, then let me tell you, when I said about the TRL 5 to 9, what about TRL 1 to 5? Now in TRL 1 to 5, where you need to develop the prototype, you need some funding, and this is possible by BIRAC. So we call it the big biotechnical ignition grant called BIG. It's a flagship theme of a BIRAC. And you know, as it is indicated here, when if you look at my cursor, from ideation to the proof of concept, that means TRL 1 to TRL 5, TRL 4, there they give you the money. They say that, show me what are your ideation, what are your new things that you would like to develop. And then if they accept that, they will give you till TRL 5, and then TRL 5 to 9, then there are other schemes by which they fund it. Even the investor can pitch in, or rather the angels can pitch in, the venture capitalists can pitch in your product, because they have seen the successful completion of the proof of concept. And that's why I wish to tell you that two of my researchers, they are successful in getting this BIRAC grant. And one researcher, Dr. Pranav, he is successful getting the IIGP 2.0 award, and all of them have started the company. So the company they have started is the Dr. Sandeep has started CU Press Research Limited, where he has developed the surgical guide. Neha has started the company where she has developed the glaucoma detector. The Dr. Pranav, he is actually developing the scaffold. And interestingly, when you look at this Dr. Sandeep and Dr. Pranav, the whatever the product they are deploying, or whatever the product where they have started their startup, it is their PhD topic. They have actually worked on that particular work as in the PhD, and the same topic is now taken further to start the company. I don't know if I can run this one, maybe if it is possible. Otherwise, you can always see it on the YouTube. Just let me check if I can run a 3 minutes small uh, clip, but I don't know whether it is audible to everybody. Okay, let me check that. Uh, yeah,
Yes,
just
sir.
running this.
Audible.
Is it possible to hear audible?
Yes.
It's okay. Nice, nice.
Hmm?
Okay.
It's not audible.
It's not audible. Okay, okay. That's what I see. That's what actually I
Uh-huh.
was expecting, that it may not be audible. Doesn't matter. I think let me close down that. You can just 1 minute. 1 minute. Okay, I think you can always see it on the YouTube. It's not a big issue. You can always see it on the YouTube, and
Yeah,
there,
okay.
yeah, I think it's available. It's not a big issue. Okay, so let me take you back to my where I want. share. I think yeah. So I think you can see you can visit the YouTube and see that. That's what actually I have asked, like whether it is audible or not, because there are, I think, some setting is required to be done, but that's fine. Now, if when you see that, you can actually enjoy that what type of the product they have now developing through the startup. And this ecosystem, that's what I have already told you, is very important. Now, let me tell you quickly about a Sandeep. He has developed a surgical guide. Now, this surgical guide is required by the surgeon whenever he resect any organ. Now, here you can see that he has developed a flexible one where the doctor has to only put a scalpel and cut the part and then fit the implant, which actually fits properly, and there will not be any stresses that gets developed in the implant because of the non properly matching of the part. So he has developed this particular device. It's always already he's in the trying his this particular device to bring in the market under the TRL 5 to 9, and he got the Nidhi Prayas grant also. He also won the 1,000 euro award from the Mimics. It's a award by the Materialize, and he was the second in the world. So what I'm interested in telling you, that all these things you can see on the YouTube, which is already available. But I would like to tell you that we are now interested in rather practicing a theme which we call it as engineer your research for startup. Now, this engineer word, I'm using it here as a verb. The engineer your research, whatever the research you do, see that it will lead to startup. And everything we already discussed. So please do visit our symposium, which we have done it somewhere in the March 21. So it's already available on the YouTube. And there, what I would like to tell you, that in this particular symposium, or rather in this particular theme, we do want that it is not about the PhD. Any research that you do, where you are in a position to file the patent, it will be possible for you to get a start. Okay. So that is, I will request you to just visit that. And another interesting point about the startup is the sustainability oriented innovation. Now, I'm just showing you here a simple figure. There is a bullet train and there is a kingfisher. Now, you know what this kingfisher has to do with this bullet train? The shape of the engine is actually developed with mimicking the shape of the kingfisher beak. It is because otherwise there was a sonic boom when this train used to pass through the tunnel, and the Japanese people, they used to get disturbed whenever such type of the sonic boom used to come. Now that engineer who was actually developing this particular frame of the engine, he was a bird watcher. Then he has seen, oh, when the kingfisher enters from the air to the he dashes in the water and then catches a fish and go back, there is hardly any sound. Then he studied that, and the same concept is mimicked in the design of the bullet train. And you see, this becomes a sustainable oriented innovation. Now, till today, the shape is not changed because it has come from the bionics. So, what I would like to tell you here, that all these things is very important when we actually look it from the research point of view, from the 3D printing point of view, and when you talk about from the industry 4.0. So finally, let me conclude. And as I already mentioned, the conclusion is very important. And I told you at the start of my lecture that I would like to put more and more things in the conclusion. So then, writing so much of text is always a big issue. How many people can read the text? But they say that the picture is worth 1,000 words. So I'm showing here an interesting picture which all of you can see, and hopefully all of you will uh, understand it well. Like, we show the Betic VNIT as a tree where we attract the students and innovators and come and work with us, so that they will actually enter into the startup, and that startup will come out with the innovative medical devices. So these innovative medical devices, which are, again, remember, they are made in India. So ultimately, we do want that the people, they should climb the ladder to which we call as the Atmanirbhar Bharat, and then pick up that innovative medical devices. And then only the society will become happy. Otherwise, medical device is innovative. And if the people, they say that, oh, it is from India, we don't want to use it and all that. I think then the whole purpose will be lost. And that is what we are more interested in. And everything is possible with the sun. And then Betik IIT Bombay is helping us in getting all these things executed. And finally, before I show you my thank you slide, let me show you these 2 points. The startup as a technology-led innovation. Remember here, link with whatever I had discussed earlier with Industry 4.0, how the research institute should come together now, and ultimately why the startup is the only solution, and that is how it will lead to innovation. That is important. Secondly, the sustainability oriented innovation. Innovation should not be that once you have innovated any product, then it is not sustaining. Again, remember the 3 R's, whatever I have discussed with you. Let me show you here the new so-called the floor that we are now constructed in our CAD/CAM center, where we will be operating this biomedical engineering and technology innovation cell called Betik VNIT. Here, what exactly we are our purpose? Now I'm showing you the same figure, but now what I'm indicating here that if you have a patent, then see that it is deployed in startup. Or if you have already done the PhD, that means the research is very well proved, then we will offer the students the postdoc fellowship for 6 months so that they can now apply for the funding for TRL1 to TRL5, like a Barack Big and all that whatsoever. So our approach is that whosoever do any research, he will be mentored in Betik VNIT, and that's a virtual incubation. And there we do want that a more and more startup in the medical device sector should come up. And remember here, we always used to say there has to be the fire in the belly if at all you want to start the company. Now, what is the fire in the belly? An interesting cartoon I would like to show you here, which I have seen it in Economic Times long back. So the what he's saying. The day I was to join the revolution, I got the call letter from IM, and therefore I cannot continue with the revolution, whatever you are propagating. Now here, this should not happen. Like once you enter into the startup domain, whatever comes, maybe as something surprise to you, maybe as a gift to you, other than the startup, please ignore that. Then only you will be successful. And the vibrancy that our students, those who are the researcher earlier and now they are the CEO of the company, the vibrancy they create, I think it is something which is very difficult to imagine. And you find that the research institutes are bubbling with the this type of a vibrant nature. Sign IIT Bombay, Venture Center at Pune, all these are the very good examples where you can see that the startups are there and they now are actually working so hard with their innovation, and that's what exactly the future we wish to see, as Nandan Nilikali has said. So thank you very much for patience hearing. I think I'm right on the time to complete my discussion. And yeah, thanks a lot. And my email address is here, amk2010. So thank you, sir.
Okay. Thank you, Professor Kuthe.
Yeah.
Great professor, explaining a great technology. 3D printing, an important pillar of Industry 4.0. Dear participants, we have just observed that VNIT has done a pioneering work in 3D printing through its CAD/CAM center under the leadership of Professor Dr. Kuthe. Sir, you have presented the complete view of the technology and the success stories, the startups, etc. May I now appeal the participants to ask if they have any queries. Okay, Mr. Yudale.
Okay, thank you very much, sir. Myself, Umesh Urade, lecturer, Mechanical Engineering, Government Polytechnic, Aurangabad. Sir, today by listening your lecture, I am very, very happy. And I would like to be very happy that I have done one course of IIT Bombay, that is Design Innovation by B. Chakravarti, sir. and in that
Okay.
I think B Ravi sir also deliver 1 2 lectures on that implant, sir. So
Oh,
I was
nice.
very happy. And it is really, sir, for mechanical engineering, it is really a new vision you have given, that up till now we were not thinking about that branch of biomechanical engineering. Sir, my question is that
Yes.
just I want to ask you that when we are now designing these implants
Yes.
for insertion into the human body, so
Yes.
there is also one part which is known as our tissue,
Okay.
muscle tissue. Okay.
Okay.
So whether any research is going on in that direction, sir, that whether we are making the artificial tissue, म्हणजे मराठीत मी विचारतो सर, आपले म्हणजे शरीरातले जे टिश्यू जे आहेत, जे जसे
Oh.
आकुंचन पावतात, प्रसरण पावतात आणि ते जे रिएक्शन करतात, तर त्या टिश्यू वरती पण काही काम वगैरे चालू आहे का सर कुठे म्हणजे?
म्हणजे if I'm not wrong, you are talking about the ligaments, uh, the muscle ligaments and all that.
Yeah,
That's what you.
yes,
Okay.
muscles.
No.
Yes, sir. Yes, sir.
Yeah. Nice. Very nice question, Umesh, and I hope that whatever you have rather expecting, a lot of research is going on the soft tissue engineering. A lot of research is going on. But when we look at it, when we look at the research from the mechanical engineering perspective, I think we need to always think about the load bearing. And at present, the whole focus is on the bone, which is hard tissue and which is actually fitted with the implant where there is always a load acting. So yes, a lot of work is research work. It's not a deployment anywhere, nowhere deployment. Some success about the skin development is there, but about the soft tissue development, which is implanted into the patient body, no, still not done. A lot of research is going on. MIT under the Dr. Langer, they are doing wonderfully well. But ultimately, the way I told you about our work related to the implant, which is to be fitted into the patient body, they are only about the hard tissue. म्हणजे हार्ड टिश्यूवर खूप काम करतात आणि आपण त्याच्यात सक्सेस पण घेतलेला आहे. पण सॉफ्ट टिश्यू इज नॉट मच because it requires a lot of approvals from the ethical committees, and not only that, it's like living body. Remember here, it is a living body, and we are now coupling the non-living things with the living things. So to the bone, somewhat it is acceptable, but still I have discussed in my lecture about the stress shielding, where that is always a big issue, and therefore a lot of work is going on in the bone tissue regeneration. Okay, still load bearing tissue or the scaffold is still not possible. It's still under the research. We are doing the research in CARCAM Center, and a lot of work is being done in ISC Bangalore under Dr. Basu. So a lot of work is getting done, but deployment, no, नाही झालं अजून, तेवढं नाही होऊ शकणार. It needs some time, but yes, it is possible. It is possible.
Okay, thank
Thank
you.
you very much, sir. Thank you, sir.
Yeah.
Yeah. Anyone else?
It will be quite interesting for me to have more and more questions, and that's why at the end of the slide I just given the even email also. So just keep on sending me as many queries as you can, because that will also upgrade me also. That's what is required. And nowadays, as I already mentioned to you, that information is available everywhere. That's not a big issue. What is required, what is needed is that how this information should be converted into the knowledge, and how this knowledge gets deployed for the benefit of the society. And for that, discussion, thinking is the only important, if at all we need to enter into that domain. If you don't discuss, if you don't rather think over whatever we have learned, I think nothing is possible. So,
Hello.
Yes.
Sir, myself Shinde NB from
Yes.
Sangamne.
Oh, nice. stage. Remember here, what is important? Again, I've just taken work. Maybe later on, maybe after 25 years, it may be useful. But uh, the shape memory alloys, I have not worked on that, but I think it is in discussion related to the implant fabrication, especially in case of the implants which always changes the shape and all that. This has actually I heard when we have discussed about the mega prosthesis to be used in case of a cancer patient, and that too who are affected by the bone cancer, especially the teenager, 10 to 15 years or 15 to 20 years, they are affected by the bone issue, bone cancer. There they have actually started using it, but I don't have much information about it. Yeah.
Sir, is there is any limitations uh, for the selecting the different materials while 3D printing?
3D
For
printing.
yes, 3D printing.
See, 3D print, when you actually enter into the domain of 3D printing,
Yeah.
then there are various, the classification of the 3D printing. I think you people must be aware of the FDM, the SLS, SLM, and all that. But I classify the 3D system only in three categories. The I call it as the liquid-based RP or the 3D system, solid-based 3D system, or powder-based 3D system. Now, this is the very good classification and which we can very easily remember. If you want to make it more simple, I think I can classify it as only in the two, laser-based 3D printing and non-laser-based 3D printing. So that means still simpler to understand. Now, here, when you actually enter into this non-laser-based, then the materials that are used are only the plastic or the poly. Even the ceramics and other things are also burned. But when you enter into the laser based system, which actually qualifies for all this sinter, laser sintering and all that, SLS and all that, there you can use the metals. So, but that metal has to be in the powder form. So, metallic powder, the metal which are possible in powder form, that is what is used as a raw material or the first uh, stage in that particular laser based system. So any metal which is possible to get it in a metallic form is possible. And as you say, like when we use it in implant, so it has to be biocompatible. And there are only three metals which are biocompatible at this moment. The first one is the stainless steel 316L, another one is cobalt chrome alloy, and third one is the titanium. And titanium in raw form, if you can use it, it's wonderful. But nowadays they use it in an alloy form, and the powders of all these materials are available. And therefore, 3D printing of the metal is very popular nowadays. A lot of work is going on how it is to be used in case of a implant manufacturing. But remember here that the I have already told you, man, lecture. More and more focus on the metals is again taken with a pinch of salt because that leads to stress shielding. And nowadays, look at this very interesting feature that earlier, whenever the implant is to be fitted into the patient body, the very first question anyone will ask to doctor, sir, ye kitne din chalega? How many years it will sustain?
Yes.
So,
Yes.
that time, some 10, 15 years or even 5 years back, the people used to, doctors used to say, नहीं 10-15 साल तक आराम से चलेगा जरा आराम से चलो वगैरह 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 whatever. And that time, the life expectancy is only up to 70 or 65 or say 75. Nowadays, remember the life expectancy has increased, and it is bound to increase every years onward. So when the implant is fitted into the patient at the age of 60, and if you say that the 10-15 saal chalega, then that patient is bound to stay up to 75. Now he is going to live for 90. So whether your implant is fitted till the age of for the another period of 30 years or not, see, that is what is required. And in that case, it's better to say no to the no. Yes, that's what I told you. Though the gold standard is the metal, but then try to focus more and more on this tissue engineering, where the scaffold is to be fabricated, dissolvable scaffold. All these things is the need of an hour, and that is where all advanced countries are working. Even we are also trying our best to. We have established a tissue engineering lab. Please do visit it. and it will be quite interesting for me to tell you about that in depth.
Yes.
Okay.
Thank you.
ओके येस सर प्रोफेसर कुठे आहे सर
Yeah.
रंगलेली महफिल कुठेतरी तिला आपल्याला आणि आय एम शुअर यू कॅन कंटिन्यू like anything.
Yeah.
So
And
an
they are free
eminent
to
professor.
send me the email.
Hello, sir. Hello.
Yeah,
Yes.
they would come back. Professor Hivrare,
Hi,
I think
sir.
it is time to conclude
Maybe I think
our
I'll
session.
take this as a last question. Let
Okay,
him ask.
okay.
Umesh.
Okay,
Yes.
go ahead.
Umesh. Yes, Umesh.
Umesh sir,
I'm
please
sorry,
go
sir.
ahead.
I'm sorry, sir. Time is running. So, but a simple question, sir. So when you was delivering the lecture and in that video, तर तुमच्या पाठीमागे ते मणक्याचं बघितलं सर आम्ही त्या डिस्क वगैरे जो होता ना तर त्याचं स्केलेटन होतं तुमच्या लॅब मध्ये व्हिडिओ मध्ये तुम्ही जे दाखवलं ते
Okay. Yes.
हा
It's a model.
तर
Yes, it's a model.
जनरली तो एक मोठा प्रॉब्लेम आहे म्हणजे सर ऍक्सिडेंट वगैरे झाले किंवा काय झालं तर
Oh,
पाठीच्या
yes.
मणक्याचं आहे तर तुमचं
Yes.
सर त्याच्यामध्ये पण रिसर्च चालू आहे काय तो रिप्लेसमेंटचा वगैरे
Actually, spine surgery. That is a very complicated surgery, and we have done some cases related to the some cases in the spine surgery, but it is very risky. Frankly telling you, the surgeon's expertise is very much required in that case. That if you don't actually properly implant, especially the putting the implant in the spine with the screw, that screw needs to be properly fixed. Otherwise, if it does anywhere, especially with our spinal cord and all that, then there is a chances of getting the paralysis. And therefore, a lot of work is going on, no doubt about it. And the surgeons need here more of, as rightly said by you, they need the medical model of a diseased organ, like the one which you say that behind me you have seen that. What is the interesting point here is that if you can get a CT scan of the patient and then you get the diseased physical model of a diseased organ like a spine, then the surgeon can get the surgical plan done very nicely. The surgeon always used to say that surgery is very simple. What is difficult is surgical planning. And there you will find that the most of the spine surgeons, they need the rapid prototyping 3D printing only to get their surgical plan very well set. Once their surgical plan is ready, robust, then the surgery is successful. There is no issue about it. So that's what I can do. So we have given a lot of models to these people here in Nagpur, those who are doing the spine surgery, and they have enjoyed the surgical planning, and then the most of the cases are successful.
थँक्यू सर थँक्यू सर
Thank you, everyone. I now invite my co-coordinator, Honorable Shri Kulkarni sir, to express vote of thanks.
Thank you, sir. It was the lecture on 3D printing, which was for all of us a masterpiece lecture. It is a sample masterpiece lecture for all of us, how to organize the lecture, how to deliver the lecture, how to quote the different examples, and what we can say about that, sir. It is really a lecture which is guided us right from the bookish knowledge to the entrepreneurship. So we learned the CAD CAMs, 2D files, 3D files, assemblies, details, stress analysis, all that. But without knowing the last end of that, how for where it can go, right from the pattern, moldings, and simulations. And you told the further all parts, which give us a very good vision of our knowledge, uh, which is signifying that knowledge. Otherwise, without knowing that, just delivering the 2D, 3D, and stress analysis, HCAM, all that things are of no use. So this lecture guided us in CAD/CAM in very well manner to all of us. Definitely, it will give us the insight for the startups and to increase our extent of work in this CAD CAM. Definitely, you have given the examples of your own institute, which is uh, always a guide for us. Thank you, sir. It was a lecture which we don't want to end, but still then there is a
That's
time-bound program. Definitely, we feel that we will meet again for
yes,
some or other reasons in this
yes, sir.
CAD CAM
Anytime,
and
anytime,
your guidance,
anytime.
precious guidance.
Yes,
So
yes,
very nice to hear you. All of the 2 hours, we never look anywhere from the screen. Very very valuable guidance to all of us, sir.
yes, sir.
Thank you very much, sir. Thank you
Thank
very
you, sir.
much.
Thank you, Professor Kulkarni. And as you say that you don't want to end the lecture, so is my case. I don't want to stop interacting with you also. But anyhow, I think the time is a
Yes,
constraint.
sir. Yes,
So can I leave the
yes.
system now, sir?
Yeah.
Yes,
Thank you.
sir. Yes,
Yes,
sir.
sir.
Thank you, sir.
So
Yes,
thank
thank
you,
you. Thank
Raju, and thanks to
Thank
all.
you.
you. Yes,
Yes,
sir.
Okay.
sir.
Thank you.
Thank you.
Thank
Thank you.
Okay. So all participants, thank you very much for being with us. And as usual, kindly submit the Google evaluation form and also the attendance. Thank you. We shall meet tomorrow again.
Thank you, sir.